Hi everybody, welcome back to the channel. Today's Down and Dirty. We're going to talk about the difference between 2D and 3D machine control, because that's kind of a confusing topic for people, one, who are just getting into the industry, but even people who have been in the industry but don't have any experience with machine control. It starts to sound really complicated right off the get-go when you start going, well, do I need 2D? Do I need 3D? What's overdig protection? What's all of these things? I don't know. We're going to talk about that today. So we're going to start with a dozer, because that is what our industry knows for the longest with machine control. So what is the difference between 2D and 3D? We're going to start by talking about 2D machine control. So we've got our little Cat D5 here, and you're going to notice we don't have any mass, we don't have anything on the machine to indicate this thing has GPS, which is what we've traditionally thought of when we think of machine control. But this unit can still have 2D machine control. 2D machine control, we would have a sensor, we would have a couple sensors here on the blade that would be able to determine the tilt and pitch of the blade as well as the angle. And then we're going to have a couple sensors on the main tractor itself that are going to measure pitch and roll. What that's going to allow us to do is tell the computer inside the cab here, we can tell it we want to carry a 2% pitch. And what the machine's going to do is it's going to know that it needs to tilt the blade over to a 2% pitch. And then as the tractor starts to roll into that 2% pitch, it's going to roll the blade back to maintain the 2% pitch. So we can do a cross slope and we can do a main fall slope using just the tractor itself, measuring where it is relative to the orientation of the ground. Now, the one component that's missing there is height. We cannot set a height that we want to cut 2 feet down with this dozer, because everything we're using to tell the dozer how to position itself is internal to the dozer itself. You don't actually have anything inside the dozer saying this is where we are in space. For all we know, our dozer thinks it's here. But what if we move it over here and flip it sideways? Well, it has no idea that we just went up 15 to 20 feet in elevation. It has no idea that we've moved over, to the southeast 50 feet. The dozer doesn't know that. It just knows that it needs to keep this blade at 2% as we go downhill 1%. That's the only thing the dozer knows. Now let's switch over to our excavator. Here we've got our excavator, and on an excavator, generally you're going to see a sensor somewhere here on the dog bone. That's going to be your bucket sensor. You're going to see one up here on the stick, and you're going to see one up here on the boom. And what that's doing is the exact same thing as it did in our dozer. It's telling the computer in the cab of the machine where all of this is in relation to, really the reference point on most of these is going to be the turntable of the machine. And so because we've programmed into this thing, and that's one of the things that you have to calibrate on these systems is, how far it is from this pin right here, your bucket hinge pin, down to the tip of your tooth. We have to actually manually input that into a 2D system, because we have to tell the machine where this stuff is so that as it measures the movement of all of these functions, it can calculate exactly where this bucket tip is in relation to our turntable. And so we get all of that oriented, and now what can we do in an excavator? Well, we can very easily say, okay, I want to dig 4 feet down from this benchmark. And so we would turn our machine, we would touch our bucket down to a benchmark, and we would zero out the machine. And what we've done there is we've told the machine that this bucket position that I'm currently at in this very moment is my 0 point, and then I want to dig 2 feet down from that. And so as long as our tracks don't move, boom, we swing over our hole, we dig down, and the machine will be able to tell us when we've reached 2 feet in vertical excavation straight down from the machine. Now we can get a little fancier with it, because this is now capable of doing slopes as well. We can tell the machine we want to come uphill at the machine at a 2% slope, and we want the bottommost part of our trench to be 2 feet under the machine. Boom, no problem whatsoever for a 2D system. But what happens if we have to move our machine? Remember what we said. We're using everything internal to this machine to figure out what we need to do with the bucket. So if we take our machine and we track backwards 15 feet, and in that 15 feet we go up in 3 feet of elevation, The machine here has no idea that any of that has happened because it's all referencing these internal sensors to the machine. We don't have any external points that the machine can go, whoa, 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 we're going uphill, and we just went uphill 3 feet, and we're actually kind of sitting off to the right just a little bit, and we need to account for all that. The machine has no idea. As far as the machine knows, we're still sitting back over here in this position, and we're still digging happily down to 2 feet with whatever our tracks are sitting at. And so that's one of the limitations. In fact, that is the biggest limitation to 2D machine control, is because you're only referencing things from within the machine. The system we can't just track out to another spot on the job and just immediately start digging, and the machine know exactly what we need to dig to and exactly what slope we need to put on it. Because all the machine's doing is taking inputs that we give it and then measuring those against where the bucket or the blade is. That's where you need to step into 3D machine control. And that's what we've traditionally known on the job as GPS. And what that does is it adds a next component into this whole thing, which is an outside receiver. And we're going to represent my little finger over here as the base station. What the base station does is it receives signals from the satellites as well as your machine. They're both receiving information from satellites. And then this machine is talking to my base station. Using my rover, which if you're not familiar with GPS systems, the rover is the little thing that the little pole with the screen on it and the little dish at the top, that's the guy that your grade checker's carrying around. We use that rover to communicate with the base station, and we tell the base station, look, Mr. Base Station, you right here, way over here at the job site, you're sitting at 953 feet above sea level, and you're sitting at this exact GPS coordinate. So this base station is a known point by which we can reference everything else on our job site. And so I'm gonna pull my finger away, but just envision, we still got our base station here, right? So now when I take my little dozer and we drive ourselves back over here to this area of the job site, my dozer knows exactly where it's at in elevation. And the other powerful thing about GPS or 3D systems is we actually load site files into these machines. I did forget to say, with a 2D system, you're not generally going to have any sort of site plan in the computer simply because there's not really a point. Your machine doesn't know where you are in relation to that site plan. So if we're over here at the southeast corner and we want to track all the way over to the northwest corner, without the 3D system, without that GPS component, your dozer has no idea where you are. And so that's why when we get into GPS, we're going to load a site plan in this baby, because now I can drive all over the site. I can tell you where every catch basin's going to go, every manhole's going to go. I can tell you exactly where the curb line's going to be when this is still just a flat dirt farmer's field. That's the beauty of 3D GPS. So now comes the question of who needs 2D and who needs 3D? How do I even figure out what I need? Well, first of all, 2D is going to be significantly cheaper than a 3D system. A 3D system, you're easily looking at probably 60 to 90 grand to get into, and then you're going to have to outfit your actual machine. That's right, for the 60 to 80 grand, that doesn't mean you get a dozer that's equipped with GPS. That's just to get your rover and base station and your basic components. Then you're going to spend another 30 to 50 grand on getting your dozer outfitted. Yes, it's that expensive. This is why the dirt industry is a rough industry. It's expensive. So if you're doing residential jobs, small commercial site work, maybe even some basic pipe work where you have reference points and benchmarks available to you, that is a great candidate for a 2D system for an excavator. You don't need to have everything programmed into the machine. You just need to have a consistent touch point. Or, one thing I didn't mention with the 2D system on this guy, mostly we would use it on this guy. You can use it on dozers as well, but mostly we're going to use it on our excavator, is a laser catch. And so on our sensor here on the stick portion of the excavator, we would actually have a laser receiver. You can get a mast for dozers that will also have a laser receiver out here. And what that does is, just like a grader out on a job site, it gives us a consistent flat plane within reach of the laser that tells our machine this is a known elevation. We can tell our machines this is this elevation. And so as long as we can reference that as we drive around, our system, our machine isn't going to know exactly where we are in space, but it will know what our elevation is relative to our laser. And so that's a great, we could absolutely dig in some really long pipe runs with an excavator with a 2D system. With dozers, you can do all sorts of ditches and barn pads, and you can do all sorts of relatively simple grade work because you only need the slope and the cross slope. And that's totally attainable with a 2D system. So when do we need to step up into a 3D system? Well, if you're starting to get into residential subdivision developments, if you're starting to get into some more complicated site plans on the commercial side that may require some very exact prints that you have to follow. Well, you step into a 3D system, now you not only have the entire site plan on the screen inside the machine, but you don't have to pay a grade checker to run around. You're not out there pulling measurements to try to figure out where exactly that curb line is. And if we're all familiar with how often grade stakes get hit on the job site, you're not paying a surveyor to come out and restake the same curb line or the same meter box or whatever it is for the 18th time because your scraper guy ran it over again. That's the beauty of a 3D system, is you really, like we talked about, you step up substantially from a price point, but you also step up substantially in the capabilities that are available to you within the machine itself and within your ability to follow that site plan to a T. So as always, I hope this has been helpful. I hope it kind of gives you a little direction as to what these systems are and how they're different. By the way, one final note, you can take a fully outfitted 3D system on something like this or your dozer and use it in 2D mode. Almost all of the machines that are shipping these days have the ability to kind of go into dummy mode, if you will, when you don't have a base station on the site. And so you lose the ability to know where you're at in space and what your elevations are, but you still have all of the grading functions available to you that just a basic 2D system would provide you. So that is one advantage of the newer components and the newer systems that are going in these machines. If you do invest in that 3D system, you can also use it as a 2D system. So I hope this dispels a little bit of the confusion. As always, if you've got any questions, drop them down below. Thanks for watching, and we'll catch you on the next episode.